to Algebra with Miss Schwartz. So we've already kind of introed compound inequalities in class. So now we're going to take a look at some examples of what they look like. We've gotten a good grasp probably on and compound inequalities, but remember we have two types of compound inequalities. We have and or. So we're going to look at kind of both of those, talk about how we solve them, talk about how we deal with them, and what those look like. So let's get started. It says, write each sentence as an inequality, graph each inequality. So our first one says a number x is greater than -8 and less than or equal to 4. So we're going to write this as an inequality. When we see the word and in here, that should kind of give us an idea, okay, what this might look like as an inequality. So let's start with the first part. A number x is greater than, okay, -8. Okay. And then the x is also less than or equal to 4. So this kind of gives us an idea of what this will look like. You can write it like this. You could also write it like this. Okay, either one works. Just depends on how you like to see it. Okay, but then it asks us to graph it. So if we look at the graph here, I gotta go from -8 to 4. So if I start at -10 and go up by 2s, sorry for the bell there. You have to make it longer. I guess I didn't really have to. Okay, so I'm going to graph wherever a solution would be. So x is going to be greater than -8. Okay, I have an open circle at -8 because it's not greater than or equal to. So it's going to be to the right of -8, but it's going to be less than or equal to 4. So I can do a closed circle at 4, and I can shade everything in between. So as we already talked about, this is called an intersection. Okay, they intersect here. These are the solutions kind of run into each other. So here's an and compound inequality. So B says a number y is at most 0 or at least 2. Okay, so what we're going to do is kind of split these up into two pieces. A number y is at most, okay, so y is going to be less than or equal to 0, because it can't be more, but it could be 0, or at least 2, so y is greater than or equal to 2. These are my two pieces. Notice our and inequalities, we don't see the word and in it, but our ors, okay, that's how we write it. So now we just need to graph these. This is going to be a union, is what we're going to see. Okay, so let's go -2, -1, 0, 1, 2, 3, 4. Okay, so we have a closed circle at 0, but y is less than or equal to 0, so it's shaded this way. So anything less than or equal to 0. And then we have y is greater than or equal to 2. So 2 could be a solution, but everything to the right is shaded. So notice there's some pieces missing in here, but everything this way and everything this way is shaded. So hopefully with the graphs you see the difference between an intersection, our and inequalities, and a union, our or inequalities. So you'll have a few of those where you're writing the inequality. Make sure that you recognize if it's an and or inequality when you're writing the inequalities, and then you're graphing them. And they should look Okay, if it's or, it should be a union. If it's and, it should be an intersection. All right, so then we're going to take that information and now we're going to solve inequalities with this and graph their solutions. So number one, this makes it really easy for us. It's an or inequality. So really, it already breaks it down into two pieces for us. We have 4c plus 3 is less than or equal to -5. We're going to solve that one. And then we have or c minus 8 is greater than -1. And we're going to solve that one. So we just work to solve these. We already know how to solve inequalities. So we're trying to get c alone. So we get -8 there. Divide by 4. I didn't divide by a negative, so nothing needs to change with my inequality. C is less than or equal to -2. Then I'm going to add 8 to both sides. C is greater than 7. So notice when you have or, your arrows are going to be going in opposite directions if your variable's in front, because you're going to have that union where they're going in opposite directions. So if I do -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to have a closed circle at -2, and it's going to be shaded to the left, and an open circle at 7 shaded to the right. Well, there is our union. They're heading in opposite directions. Okay, so make sure you have that written down. On number 2, this looks a little different. This is our and inequality. We don't write and, we just have them in two pieces. They're kind of combined together. They're going to intersect. So I can break these apart into two different pieces. I can say, well, 5 is less than or equal to m plus 4, because that's what this part says. And then m plus 4 is less than 10. And I can solve both of these pieces and then graph. So I'm going to subtract 4 from both sides. So m is less than or equal to, 1 is less than or equal to m. And then I can subtract 4 from this side, so m is less than 6. If I wanted to, I could bring these back together. 1 is less than or equal to m, which is m is less than 6. So now I just need to graph it. So I got 0, 1, 2. Okay, I have a closed circle at 1. Okay, m is greater than or equal to 1, so it's going to be shaded to the right. And then I have an open circle at 6, but m is less than 6, so it's going to kind of come together here. Our intersection. Make sure you have that one written down. All right, so we have some more examples here. I'm going to do one with you. Both of these are and inequalities. Okay. And you're going to try one, and then we'll go to the next slide, and I'll try one more, and you'll do one more. So I'm going to break these apart. -4 is less than x minus 2, and then we're going to also have x minus 2 is less than 3. So I'm going to solve to get x alone. So I have -2 is less than x. Get x alone here. X is less than 5. So I could bring it back together if I want. There's my inequality. I'm going to graph that. So let's go -3, -2, -1, all the way up to 5. So I'm going to have an open circle at -2 and an open circle at 5. X is greater than 2, but x is less than 5, so we have this intersection here. So go ahead and try number 4 on your own. And I'd like to see that one once you're done with that one to make sure you kind of understand. So this is another and inequality. All right, last couple here. I'm going to do the or one at the bottom. You're going to do another and one. So you're going to do A, but I will do B with you. So make sure you have these all written down. So we have 4x plus 1 is less than or equal to -11. So I'm going to solve that. So I have 4x is less than or equal to negative 12 divided by 4. So x is less than or equal to negative 3. And then 3x minus 4 is greater than or equal to 5. So I'm going to add 4 to both sides. 3x is greater than or equal to 9 divided by 3. So x is greater than or equal to 3. So as you can see, they're going in opposite directions. If I graph this, might need a little bit of space here. So negative 4. Okay, I have closed circles at both negative 3 and 3. And it's less than, so this would be this way. And this one's greater than, so this would be this way. And that's our union. They're heading in opposite directions. So you're trying A. You already did the one on the previous problem. I'd like to see those to make sure you kind of understand. Once you're done with that, you have some homework, page 51 and 52 in your journal. Have a great day.